Okay, so question 1. Which of the following will reduce random errors in an experiment? I hope you all can get this. All of these are looking at systematic error, checking for the zero, checking calibration, greater precision. These are all looking more at the systematic error, but D, the repeated values, will reduce the random errors. So 1D is correct. Then it says a body accelerates from rest with a uniform acceleration a for a time t. The uncertainty in a is 8% and the uncertainty in t is 4%. The uncertainty in the speed is. Now, we know our general formula for this is that a is equal to our change in velocity over our time. So our change in velocity is going to be our acceleration times time. Now, here our change in velocity here, we are looking for the uncertainty in the speed. All right, so we're looking at that value there. We're looking at our final speed, I suppose. We're going to get here our change velocity is our final minus our initial. But because we are at rest, that is just going to be v minus u, which is 0. So that's going to be v is going to be at, like that. Now here we're going to use this formula over here where we can find our uncertainty of how many percent, and we follow through like this. So your uncertainty in V over V is going to be our uncertainty in A over A plus our uncertainty in T over T, like that. And we have got, for this, we have got the A, the uncertainty in this. Now, these two together will give me a relative error. And then when I multiply it by 100, I'll get a percentage error. So this is 0.08 plus, and for the time is 0.04. So when I add the two together, I get 0.12. That will be my relative error. And my percentage error, therefore, will just be that times 100, which will be 12%. So your answer for this is B. Question 2 is B. Which of the following lists two scalar quantities? Now, your EMF is your electromotive force. This is actually your voltage and your momentum. So those two, the momentum is a vector. Your weight is a vector because it's a force. Your impulse is a change in momentum, and that has got a certain direction because momentum is a vector. So D would be the correct one, your temperature and your kinetic energy. Question 3 would be D. So this really required that you had this knowledge of knowing your vectors from your scalars. Remember with this that a vector is something that has got both magnitude and direction. It has direction also, where a scalar we're not worried about the direction, so it's just the magnitude, it's just the value. So if something is acting in a certain direction, then we can think that it's always going to be a vector. Alright, here we have a graph, shows the variation with time t of the acceleration a of an object. Now, with this, it says which of the following is the change in velocity of the object. Now, when we're dealing with graphs, usually we're looking at either the slope or the area. And we know that for an acceleration time graph, our area is equal to our velocity, is equal to our either velocity or speed, whichever one you're dealing with. So the area is my velocity. So here I have a triangle, so I'm going to get half the base, so it's going to be half times 4 times 4, and that is going to be 16 times a half, which is going to be 8 meters per second. Notice that your units actually cancel out because you've got a meters per second to the minus 2 times a second, and that's to a 1, and that cancels out to meters per second to the negative 1. So we know that our area, when you work out the area, you are getting a velocity term. Now we've got 2 with 8 in, and it's just to decide whether this is going to be negative 8 or plus 8. Now, when we think of this, when it starts off here, it starts off with a positive velocity of 4, and it goes down to 0. A positive acceleration of 4, and that drops down to 0. So your change in velocity will therefore also be positive. So that is going to be D. Will be the correct answer. This area here is positive, and therefore it will be a positive velocity. Don't be fooled that the acceleration is decreasing, but still the velocity is increasing all the way until we get to this point over here, where the velocity stays at a constant velocity. Here we have a car accelerates from rest. That's important. The acceleration increases with time. Which graph shows the variation with time t of the speed v of the car? So we've got a velocity time graph. Now, we need to remember, for a velocity time graph, the slope is our acceleration, and the area underneath the curve is our displacement. And we can see that for a slope, because this is meters per second and this is seconds. When I find a slope, I divide this by the seconds, giving me my meters per second to the minus 2. So we can see that the slope is equal to your acceleration. Now, which one of these will be correct? So we can use that. Now, we've got it's from rest, so your velocity, it accelerates from rest, so your velocity must start off at 0. So we've got these two are starting off from 0, so it can only be those two. These two cannot be correct. Now, it says the acceleration increases with time, therefore your slope is going to increase. Now, which one increases? This one over here is increasing, so it is going to be 5b. Question 6. Which of the following is the condition for a body to be in translational equilibrium? So translational equilibrium, basically it's moving in a straight line with a constant velocity, or it is stationary. A is the correct answer. The resultant force on the body in any direction is 0. Because it's in translational equilibrium, your velocity is constant or 0, so there's no unbalanced forces in it. Just look at the other answers why they're wrong. Velocity of the body in any direction is 0. It doesn't need to be. It just needs to be that it's a constant velocity. So that's not correct. No external factor, the force is acting on the body. There may well be an external force, but it's balanced out. For instance, I may have an object that is falling through free space at terminal velocity. It therefore has got a force of mg acting on it in that direction, but a frictional force in that direction, and these two are balancing each other out. They're cancelling each other out. And because they're cancelling each other out, there you've got mg minus the frictional force is equal to 0. This would be in translational equilibrium. But there are external forces acting on it, but they are all cancelling each other out. And no work is done on the body. You may have a situation where you have got a book on a table and it's moving with a certain velocity. Now, to keep it moving in that direction, because of friction, you have to apply a force in that direction. And obviously your frictional force will be operating in the opposite direction, cancelling out that force, but you've got to overcome it. So you're actually doing work. Work would equal to force times the distance that you have actually moved in that direction. So it can be that work is done on the body, but again, all your forces are cancelled out. Going on to question 7. This is dealing with circular motion. A stone is attached to a string, is moving in a horizontal circle. The constant speed of the stone is v. The diagram shows the stone in two different positions, x and y. Which of the following shows the direction of the change of velocity of the stone when moving from position x to position y? Now, so we were moving in that direction with a certain velocity, and after there was this change, we landed up going in that direction. So that this one over here is the final velocity. This is the change. So what caused the change? That must be the change in that direction, because this is the initial and this is the final. So this must be the change in the velocity there. And so it would have to be D. It would be 7D. Now all of these, obviously, I haven't actually needed to use them much, but all of these are these over here. Well, so they are for Unit 2. I'm just about finished with Unit 2 there. Here we have the graph shows the variation with force F of the extension of a spring, extension S of a spring. The work done in changing the extension of the spring from 3 centimeters to 6 centimeters is. Now again, from the graph, you need to decide, is it the slope or is it the area? Now we know that work, and here's our formula over here, that work is equal to Fs, or force times distance. So here we are going to have a multiplication, and that is going to be my area. If I multiply this, if I find my area, it's going to be an F times an S value. It will be a Newton times a centimeter. We're actually given it here, aren't we? We're given it. So that really is a clue also. We're dealing with the area. So, but we're going from 3 to 6. This is a little bit of a trick question almost, because easy just to go from 0 to 6. So we've actually got to put this in there. We're going from 3 to 6. So we're actually looking for that area there only. So I'm going to work out the whole area. I'm going to work out the whole area, which is going to be 20 times 6. 20 times 6 divided by 2 will give me the area of the whole triangle. And then I'm going to subtract the blue part minus, that's going to be 10 times 3 divided by 2, because it's a triangle going up to 10 and along to 3. That one over there, that obviously is going to be 60 minus 15, which is equal to 45. So I have got C.